All right, you guys. Let's try sines and cosines take two. The objective again, we're going to look at sine and cosine, how these functions, finding values of these functions, and solving simple trigonometric equations. So to get started, let's talk about what the definition of the sine of an angle is and what the definition of the cosine of an angle. So in general, the sine of any angle is going to be given to us as y over r on any, well, I've drawn a circle, which I'll talk about in just a second. So if of course, this is my x-axis, if I were to draw something like this, so this is my theta. If I want to talk about, or I want to define, I'm defining the sine of an angle as y over r. If I drop this straight down, I think this will help teach this a little bit. When I'm talking about this point on the circle, this, of course, is the y value. This is the r value. You probably learned about SOHCAHTOA once upon a time. Yeah. And sine is opposite over hypotenuse. If you think about that right triangle, you see opposite over hypotenuse. So when we get into this section, there's a chapter on triangle trigonometry later that's a very easy chapter. But that'll come later. But in general, we're defining it as y over r, which, again, follows with what you already know. And the cosine of an angle will be defined as x over r. And you learned it as adjacent over hypotenuse when you do triangle trigonometry, where this is the x value, of course, over r. No matter what angle we have, you're always going to have this concept. So you got y over an r, and it's just a ratio. Y over r and x over r is, by definition, what we're talking about. So, and it doesn't matter what quadrant we're in as well. Now you might look at it and think, well, what about, so if I have something over here in quadrant 3, you know, and I have this point, of course, xy, the angle I'm talking about is that angle, but you want to bring it to the x-axis, so this is the idea. This is your y value, this is your x value, and this is your r value. So when you think about that one in quadrant 3, just looking ahead just a little bit, when you do the sine of an angle then that is between 180 and 270 degrees, which reminds me, maybe we should review those special angles again, because we'll probably have a quiz on that maybe by the end of the week. One of those quizzes, a great way to start out semester 2, because you can all get 100% on it, because you know exactly what the question would be. If you want me to do that, remind me at the end, or we can do it now if you want. Should we do it now quick?
Let's just do this.
Keep rolling?
Yeah.
Okay. We don't need to take 3. No. But what happens in quadrant 3 when you do y over r or x over r? I hope you recognize that either one of those, if the angle is between 180 and 270, you do the sine of that angle, the ratio would always be negative. Because your y value is negative in quadrant 3 and your x value is negative in quadrant 3. Are you with me on that? In quadrant 2, if I looked at doing something similar to this in quadrant 2, so I have something, so here's my initial ray, and we go this way, so I'm talking about this angle, so here's my x and here's my y. If you think about that, your y value will be positive, but your x value will be negative. So in quadrant 2, if your x value is negative, my cosine will be negative. And I'll summarize that in just a little bit, what I'm doing, what I'm talking about. All right, so let's do an example of this. So let's say the terminal ray goes through the point negative 3, 2. So I just have a circle, and my point negative 3, 2, I'm just going to say it's right here. So I have an angle that looks like this. If my terminal ray goes through that, I'm talking about this angle. My initial ray is, of course, the x-axis. And we're measuring it counterclockwise. So if I wanted to find the sine of that angle and the cosine of that angle, it really isn't too bad. The sine of the angle, the cosine of the angle. The sine, again, the sine is y over r. So if you think about making a triangle right here, again, always go to the x-axis and you're going to be in good shape. You make a right angle right there. You know that this side is 3. Technically, it's negative 3, but I'm just going to say it's 3 for purposes of what we need, and that is we need to find the hypotenuse. And we're talking about a length. If one side of the triangle is 3, the other side of the triangle is 2, the hypotenuse, x squared, a squared plus b squared equals c squared, 9 and 4 is 13, so this side is the square root of 13. You with me on that? So the sine of the angle is y over r. So in this case, it's 2 divided by the square root of 13. Now we don't like to leave it like that. We don't like to leave it like that because we have a square root in the denominator. So we rationalize the denominator, and I'll just jump to it. You guys can follow me on this. 2 roots of 13 over 13. That's the exact answer for the sine of the angle. That's the exact answer for the sine of the angle. We could plug that in and find out about how much it is. And right now, we're not at the point where we're finding out what theta is. We will. I hope some of you are wondering, oh, I wonder what that angle is. I know it's between 90 and 180. We will be in that business, but we're not in that business right now. We're just finding the sine of the angle, and we'll say 2 roots of 13 over 13. The cosine of the angle, which is x over r, and x, remember, is a negative 3 over the square root of 13. So in this case, I have negative 3 roots of 13 over 13. The exact answer for the cosine. And I could do that for any point if you want me to. Make sense? Pretty easy, pretty straightforward. I can tell you a terminal ray.
How did you get the square root of 13?
Great question. I got the square root of 13. You have a right triangle. If this side is a and this is b, we know if it's a right triangle that a squared plus b squared equals c squared. Pythagorean theorem. So on this problem, I know that this side right here is 2. I know that this side right here is 3. So I have 4 plus 9, which equals 13. So this side has to be the square root of 13. Excellent question. You'll have to use Pythagorean theorem a lot on these types of problems. Okay? So this is all we have to do right now, is just identify what the sine of the angle is and what the cosine of the angle is. You're done with a problem similar to that. Another one. In quadrant 4, I'm telling you that the sine of the angle is negative 5/13. What I want to know is what's the cosine of the angle. Now, why is it kind of important that I told you that you're in quadrant 4? If I didn't tell you that you were in quadrant 4, what would you ask? Or what would I hope you would ask? If I tell you that the sine is a negative 5/13, what would be your other option? Quadrant. If the sine is negative, that means y over r. Where else are the y values negative? The y values are negative in 3 and 4. So I know that I would be in either one of these two, but because I say that it's in quadrant 4, this is how I would draw my picture. Here's my initial ray, here's my terminal ray. I'm talking about this angle right here. Notice that I usually draw it through the circle, I don't just stop it on the circle. And I don't worry about drawing things to scale. And you guys have seen my drawings. If you had me first semester, you know what I'm talking about on that. I don't really worry about making sure it's perfectly to scale. Just get it in the correct quadrant. You know that if it's the sine is 5/13, you know that this side is 5 and this side is 13. So what does that mean, what the x value is? Now you can see that I didn't draw this to scale. I probably should have drawn it closer to the x-axis because the x value is going to be quite a bit bigger than the y value. Do you know special triangles? You know, we talked about Pythagorean theorem, a squared plus b squared equals c squared. I think we call them triplets when we teach advanced algebra. So like 3, 4, 5 is a triplet. It makes a right triangle. And if 3, 4, 5 is a triplet, so is 6, 8, 10, so is 30, 40, 50, any multiples of those, 3, 4, 5. Hopefully you also know another triplet, and that is 5, 12, 13. You've seen that one before? If you didn't know that, you can always get it by using the Pythagorean theorem. But 5, 12, 13 is a triplet. It's a pair of 3 numbers that make a right triangle. So this side is 12. Did I say that too fast? We okay with that? So the cosine of that angle, remember, we're in quadrant 4. The x value is positive in quadrant 4. So the cosine of the same angle will be 12/13. I don't know what the angle is right now, and we don't care. That's not what we're after. We're after what the ratio, what is the cosine of the angle, or what is the sine of the angle. Okay? Let's keep moving. Let's keep moving on this. Nice picture, huh? What I want you to recognize by drawing this picture, or what I want to talk about, is here's my initial ray, and here's my terminal ray. Would you agree that this angle right here is the same no matter which circle I'm using, first of all? Is that angle the same? I think we can all agree that that angle doesn't change. But what I kind of want to do is draw something like this. I'm just redrawing that angle. If I use the orange one, I'm going to get something like this. If I use the gray one, I'm going to get something like this. If I use the purple one, maybe like this, and the green one, maybe something like this. When I bring it to the x-axis, I maybe should have changed colors on each of those. Maybe that would help explain this. But when I look at the orange one, I'm right there. When I look at the gray one, I'm about right there. When I look at the purple one, we're about right there. And finally, the green one, we're about right there. What I want to mention when I look at this, so here's my angle that I'm talking about with this theta. There's my theta, which is in there. It doesn't really matter, it appears, what circle I'm talking about. When I mention something about the sine of the angle or the cosine of an angle, this one's y over r and this one's x over r. So on the orange one, this x over this r, how would that compare to the green one if I said this x over this r? Tell me about similar triangles. Similar triangles. Same shape, different size. Same shape, different size. Tell me about the ratios of the corresponding sides on similar triangles. How will this ratio right here, well, let's just make up some numbers here a second. So right there, let's just say that this is, let's just say this is 3, and let's say this is 5. So if this one is 15, what would this one be? So we say 3 is to 5 as 15 is to multiply by 5. It looks like I'd be at 25. It's the exact same ratio. Are you with me on that? The exact same ratio. If I reduce this one, I get 0.6. If I reduce this one, I get 0.6. Now the reason, and I could do the same thing with my y's. I could do the same thing with the y's, and we could talk about why they're similar, but that's geometry, so let's not go down that road. You guys agree with me that they're similar, same shape, different size, ratio of the size is the same. So if it does not matter what circle I use, that's the whole point of this. It doesn't matter which circle I use, then the most logical circle for us to use, we've studied circles, the most logical circle for me to use is this one. Tell me about this one right here. Circle centered at the origin with a radius of 1. We call it a unit circle. We call this a unit circle. It's the most logical one to use when we deal with this. Any circle will work. Well, let's use one that has a radius of 1. So thinking about this circle with a radius of 1, let's talk about sine and cosine still. Let's discuss domain and let's discuss range of each of these. And see where we go. No sleep in my class. Okay. Crossing my fingers. You will all enjoy it. So this is x. Let's get a color here that we can all see. This is x and this is y. And we know that, of course, sine of an angle is y over r. Cosine of an angle is x over r. You're getting sick of seeing it, but I think the more times you see it, the more times you hear it, it kind of sinks in. Sometimes the louder I say it and the slower I see it, maybe that helps too, right? You ever heard somebody that doesn't understand something? How do we explain something to someone who doesn't understand something? The sine of the angle. You say it louder and slower, right? Sorry if you're watching the podcast. So the domain we know, in general, domain deals with x's, right? Your input values, and your range deals with y's, your output values. So let's think about the sine of an angle, and let's think about the domain of it. Any circle we want, if I'm going to draw the circle, here's my x, here's my y, we know, let's identify this point right here as 1, 0. Let's identify this point as 0, 1 because it's a unit circle and it didn't matter which circle we used. So 0, negative 1. If you think about this, let's talk about, we'll do domain and we'll do range for sine. And then we'll talk about the same for cosine. But the domain, what do you know about the angles that I'm going to do here? If I draw this one in here, this one in here, this one, this one, this one, I'll draw a bunch of these. And when we're talking about the domain, of course, we're going like this to here, or we're going to here. Do you see any problems on what I couldn't do the sine of, in other words? As far as angles. Can I do the sine of 1 degree? How about 80 degrees? How about 95 degrees? How about 270 degrees? How about 280 degrees? How about 359 degrees? Could I go around the circle and go 365 degrees? Sure, because that's the same as 5 degrees. So what I want you to think about on the domain is all reals. You can do the sine of any angle. And maybe since we're talking about it, let's talk about the cosine as well. For the domain, all reals. You can plug in any number. Because just think about it's just the angles. Any number you want, you can plug in to do the sine of the angle or the cosine of an angle. The range is a little bit different. The range is a little bit different. The range deals with the y values of your answer. So think about as we go around this circle right here. If I pick this angle right here, here's the y value that gets associated with it. Remember, the r value on all of these is 1, because it's a unit circle. So really then I'm talking about the sine being the y value. So if I were to draw my angle in really close like this, like 1 degree, my y value is very small. With me? If I go up to here, my y value is very close to 1. My y value is very close to 1. Once I get here, it's even closer. Once I hit 90 degrees, it is exactly 1. But what happens when I go past 90 degrees and my angle looks like this? Tell me about my y value. It's less than 1. And then what happens is I come this way, my y value starts cruising back down towards 0. As you go into quadrant 3, what happens to your y value? It's getting smaller. My y value is getting smaller, and what's my y value getting close to? Negative 1. And as I cruise into quadrant 4, what happens to my y values? Going back towards 0. So what can I say about my range? My range are the numbers between negative 1 and 1. If you don't want to write it like that, we can say y is less than or equal to 1, greater than or equal to negative 1. These two things say the same thing. This is interval notation. We talked briefly about that at the beginning of the year, from negative 1 to 1 with brackets, meaning we're including it. Or you can say y is between negative 1 and 1, that way as well. Okay, that's my domain. What's my that's my range. That's my range of the sine curve. How about my range? How about my range of the cosine curve? Let's switch colors here. So if I had this here and I'm right here, I'm talking about the x. Because it's x over r, and r is 1. What happens to my x values as I go like this? So it started out right there at 1, and then I come over here and my x values start going towards negative 1. And as I go into quadrant 3, my x values start going back towards 0. And when I go into quadrant 4, my x values start getting closer to 1. So my range of my cosine is the exact same thing. Negative 1 to 1. Or I could say y is less than or equal to 1, greater than or equal to negative 1. My domain is anything, my range for both of them, negative 1 to 1. Okay? Hopefully that messy circle kind of makes sense. Think about y values, think about x values. We're using a unit circle because we showed that it doesn't matter what circle we use. Let's talk about one that has a radius of 1 when we talk about this. Okay? So, tell me about the signs. This is where we started out talking about the signs. Tell me about the sign of an angle in quadrant 1. Positive. Tell me about quadrant 2. Remembering that the sign is is y over r. So you're just thinking about the y values. What's it in quadrant 2? Positive. What's it in quadrant 3? Negative. And in quadrant 4? Negative. The cosine of an angle is x over r. So you're thinking about the x values. Well, in quadrant 1, I'm positive. In quadrant 2, I'm negative. Quadrant 3, I'm negative, my x values. And in quadrant 4, I'm back to being positive. Okay? There is a little, I don't even know what you call this, but a little thing that might help you guys if you do it this way. There's is it an acronym or something like that, or a saying, whatever. All students take calc. All students take calculus. I hope you guys will be challenged to take calculus. It will open up a lot of fields. But there's other trigonometric functions we'll talk about. We haven't talked about yet. We've only done sine and cosine, but there's one called tangent. And then there's secant and cosecant and cotangent. Those are all easy. But this, we haven't talked about tangents, but this would tell us where or what is positive. They're all positive in quadrant 1. The sine is positive in quadrant 2. The tangent is positive in quadrant 3, and the cosine is positive in quadrant 4. That might help some of you. But if you think about x's and y's, I don't think we can mess it up. I really don't. Think about but we can mix up which one is x and which one is y. I did right here, in fact. Okay? So I think that helps because it gives us a visualization of what we're going to get for an answer depending on the quadrant. I think that's important. So, let's find some answers to some of these. Thinking about a unit circle. So here's my unit circle, and I'm asking you to find what's the sine of 90 degrees. Well, we know 90 degrees looks like this right here. Sine deals with the y's. If it's a unit circle, what's the value of the sine of 90? The y value at right there is 1. So you know your answer is 1. You do not need a calculator to determine that. The second example I have, here's my unit circle, and I'm after pi, but it's a negative pi. Think about a negative pi. Now we're in radians. We might need to review that circle still of all the special angles, but negative pi means you start here and you would put you right there because there's your negative 180 degrees or negative pi. What's the cosine of the value right there? Remember, my circle is a unit circle. The x value right there is negative 1. How about the cosine of 450 degrees? I'm having a good day drawing circles, by the way. Sometimes teachers have to tell ourselves stuff. Those 3 circles are pretty good. So you might not tell me that, but I still feel good about myself as a teacher because I'm making nice circles today. Tell me about, I know it's stupid, isn't it? But it works, you know, whatever you have to do to make yourself do your job. How about 450 degrees? Where are you at? You go all the way around the circle once, that gives you 360. And then how much more do you have to go? 90. You got to go 90 more, so this is the same as saying the cosine of 90 degrees. What's the cosine of 90 degrees? We're right there. The cosine of 90 degrees is 0. And the sine of, I missed a line right here, 3 pi over 2. Now watch, I bragged about my circles and now I'm going to struggle. Where are we when we talk about 3 pi over 2? So here's where we are. 3 pi over 2 is this angle right there. So it's 270 degrees, and I'm talking about the sine, which is the y value. And if I'm talking about the y value right there on a unit circle, my answer would be -1. Nod your head if you're with me on that. Okay. So we can do this without a calculator. If you don't know how to plug these in, we should talk about that as well, but I think you know how to plug these in. Degree mode versus radian mode. Click on mode and make sure you know what you're in. We will hop back and forth often. I'm not going to do that right now, but I would like to do this without a calculator as well. Do some comparisons. So for example, if I said, what's the sine of 185 degrees? I would hope you could tell me if that's positive or negative. Not what the answer is, only if it's positive or negative. Negative. Because you're in quadrant 3, so you know that would be negative. Okay? How about the cosine of 272 degrees? How about the cosine of 272 degrees? What quadrant are you in? You're in quadrant 4, and it's the x, so it would have to be positive. How about this? How about the sine of 4? That's kind of tricky. If I just say 4, what am I talking about? I'm talking about radians. We know what pi is, right? Pi is 3.14. So where would 4 be? Quadrant 3, because it's a little more than 4, or excuse me, it's a little more than 3.14. It's more than, so you know you're in quadrant 3, so this would have to be negative. How about the cosine of 6? I'm still in radians. We memorize all those with pi's in there, but none, they give it to you this way, 6. What's the cosine of 6? What quadrant are you in? 2 pi. How much is 2 pi? 6.28. So 6 isn't quite there. So you're in quadrant 4. And the cosine in quadrant 4, cosine is x's, quadrant 4 is positive. Yep. All right. I don't know if I've got another one right here or not. Hang on. I have one of these. Solve this. This is a good one to end with. We probably should do that circle really quick. Solve for, that's supposed to be a theta. Solve for theta in terms of degrees. Solve for theta in terms of radians. And it says the sine of theta is 1. That's a good one there. So the sine of theta is 1. Remember that the sine of theta is y over r. I'm making a unit circle, so the radius is 1. So what angle am I talking about if the y value is 1? Y, 90 degrees. We're talking about this angle right here having a sine of 1. So I know that the theta would equal 90 degrees. Are there any other possibilities? We had one earlier. 450. How do you get 450? Go around and come back to 90. Are there any other possibilities? How about if I went around 3 times and then added 90? What if I went around 5 times and added 90? So what we say is this, in general, if they don't state restrictions, sometimes they'll state restrictions and say, give me all the answers between 0 and 360 degrees. Then that would be it. But if they don't state any restrictions, we would need to say plus 360n, where n is an integer. N is an element of, that's that funny e. N is an element of the set of integers. Integers is j. Now, Brooke said, what if you went the other way? Sure, if n is a -1, you're going to subtract 360. 90 minus 360 is negative 270. Is that the same answer? Could you go around twice backwards and come back to it? Yeah. So that is what we would say in general. How about in radians? What would I say? That's in degrees. What would I say in radians? What angle is that in radians? Pi over 2 plus, what did you go all the way around a circle?
2 pi.
2 pi, and then we'd have to say an n. Again, n is this element of integers. You have to add on 2 pi, 4 pi, 6 pi, 8 pi, 10 pi. There it is. You with me on that? Okay. Hopefully you can see we could write other ones as well. I mean, if the answer was 80 degrees, the same concept works. Let's do that quick circle before I give you this. Let's do that quick circle. Really quick. I don't know where my... How do I get a new page, you guys? Insert a new page. And I know you've done this already, but let's just do it really quick. Now that's a circle right there. Really quick. So 0, let's go with degrees on the outside. 0, 90, 180 degrees, 270 degrees, 360 degrees. 0 radians, pi over 2, pi, 3 pi over 2. We need to know these. Let's cut this in half. That's a bad color. Let's cut this in half. So here and here. These are 45s, so this is 45 degrees. Pi over 4. This one is
3 pi over 4.
3 pi over 4. And in terms of degrees, we know what it's equal to.
135.
190 plus 45. Thank you, 135. 5 pi over 4, and this would be 225 degrees. And this one right here, 270 and 45 is 315, and that would be 7 pi over 4. So we do our 45s, we need to know, and then we do our 30s. So this is 30, 60, 90, 120, 150, 210, to how much? 40, 270, 300, and 330. And the radian measures that go with all of those, this one is pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, but we reduce it, 5 pi over 6, 6 pi over 6, 7 pi over 6, 8 pi over 6, 9 pi over 6, 10 pi over 6, 11 pi over 6. I also think it's really important that you kind of can understand that this is 3.14. So that's why we said if you're at 4 radians, you know you're here. This one would be how much? Half of 3.14 is 1.57. So if you're at 2 radians, you know you're in quadrant 2. I think that's good to know. And you know what this one is about? It's good to know those quadrants. How much is 3 pi? 3 times 3.14 divided by 2. You add 1.57 onto that, you get about 4.671, something like that. And of course, this one, you know, is 6.28. So that helps you visualize a little bit. Because there is a couple of problems at the end, and this is really meant to be kind of easy, but you're going to be asked to compare the cosine of, let's just make up something here, 152 degrees and the cosine of 154 degrees with an inequality, like less than or greater than or equal. So let's just do that on this picture really quick. Where is 152 degrees? Well, we're about right here. Thinking about the cosine is the x value, right? So if you were at 152, you're here. Think about that x value. If you go a little bit further, you're at 154. Think about that x value. I exaggerated. Which one is smaller? Which one is closer to -1? 154. So I would say that this is greater than, huh? You with me on that? It's not meant that you plug it in your calculator and do it. It's meant to just visualize, make a picture and visualize it. If I did the exact same question, but I asked the sine of 152 compared to the sine of 154, now we're doing the y values. Here's the sine of 154, here's the sine of 152. Which one is greater? 152 is greater. For different reasons. Okay? All right. Page 272. This is the problems I was just talking about. There's like 10 problems there, or 9 problems. 10, I think. Those are all meant to be done without a calculator. They'll go pretty fast. You just look at it and you do exactly, I think, that exact same thing. Except some might be in radians and some might be in degrees, and you compare them. So we'll do 1 through 8, 9 through 15, odd, 17 through 28, 29, 31, 33 through 42. My plan, let me stop this a second.